Hello ma'am. My first question is, what is the external work done and internal energy? Please explain with diagram. Second question is, to solve the problem to find out the internal energy for different conditions of steam. That is, first condition is wet steam, second condition is dry and saturated steam, and third condition is for the superheated steam. Let us understand the external work done during evaporation process with the help of diagram. We will consider the piston cylinder arrangement. And inside this piston cylinder arrangement there is the water of 1 kilogram mass having pressure 1 atmospheric and at a temperature of 10 degrees Celsius. This water is getting heated. Then what will happen? The temperature of water is getting increased. Now we will show this with the help of curve. So here the initial condition of water is at 10 degrees Celsius. Now it is getting heated up to the 100 degrees Celsius. Then we will say that this at point B there is the saturated water condition, and why this point B is known as the saturated water at a temperature of 100 degrees Celsius, because after that if you continue to heat the water then it is getting converted into steam. That means there is the phase change process that is getting started. So after that when we give the heat, the temperature of mixture remains constant. So this point B is known as the saturated water, and in between this B to C there is the steam and water mixture. So additional heat given to this mixture that will convert the water to the steam and the temperature will remain constant. So here point C, at this point C there is the dry and saturated steam. So this point is known as the saturated vapor. So this point B to C, when this water is getting converted into water vapor, then its volume will getting increased. So this point is important. So at this saturated water and saturated water vapor or saturated steam. So now at this point B, what is the volume? Volume is known as Vf. Suffix F is there because here there is the water, that is what is the phase of the liquid, that is water, and here we will say Vg because what is the phase, that is only steam or water vapor. So here dry and saturated steam, we can say that. So here is Vg, and in between this B and C there is the mixture of water as well as steam. So we will say that in between this we will say volume is Vfg. Now we have to understand what is the external work done. So this process is taking place at constant pressure. So specific volume increases from Vf to Vg because water is getting converted into steam. So we will say that the initial volume or specific volume is Vf and final volume is Vg. So external work is done by steam to increase the specific volume. So here Vf and Vg, that means here external work or extra work that is done by the steam. So the remaining gap is known as Vg minus Vf. So I will write here Vg minus Vf. So how we can define this external work? So this external work is this process is taking place at constant pressure. So we will take here P multiplied by this difference Vg minus Vf. Now this Vg minus Vf at any point is known as Vfg because here this is the any point in between this point B and C is known as there is the mixture of water as well as water vapor, and it is known as Vfg. So we can write here P multiplied by Vfg. Now if we compare the volume of steam and volume of water, then volume of water is so much small, so we can neglect this. That means we can say that this Vf is much smaller than Vg. So this value Pvg minus Vf is approximately equal to P into Vg. So this is the final formula that we have to take for the external work done. Now there are different conditions of the steam, that is the dry and saturated steam as well as wet steam. So what formula we have to use for different conditions? So for dry and saturated steam we have to use, that is dry and saturated steam will be at this point C. Now at this point C volume is Vg. So we have to take the formula external work done is equal to PVg. And for wet steam, now wet steam, that means the location of the that point is in between B and C. That means here is VFG. So if we multiply with dryness fraction X to the Vg, then we will get the external work done for wet steam. That is Wx is equal to Pxvg. Now we will understand what is the internal energy of steam. Now its notation is U. So it is known as the heat energy stored in steam. So what is the formula? So total heat of steam is equal to internal energy plus external work done. So this internal energy is known as U, and this external work done we know it is known as pressure multiplied by specific volume, and total heat, that is H. So we can say the formula is H is equal to U plus PV. So we can also write U, that is internal energy, is equal to H minus PV. So this is the formula that we have to use for the internal energy of steam. Now there are three conditions of steam, that is the condition is the suppose steam is dry and saturated, suppose steam is wet, as well as suppose steam is superheated. Then what is the formula that we have to use? So for that we already seen that what is the formula for the dry and saturated steam, then wet steam as well as superheated steam to calculate the enthalpy H. Then we have also seen the formula for the dry steam, wet steam as well as superheated steam to calculate the specific volume V. Then we have to put those formulas. So here suppose there is the dry steam, then we have to take Ug is equal to Ug, that is suffix G is used for the dry and saturated steam, which is equal to Hg minus P into Vg. So instead of volume V we have to use the suffix G. Then we will calculate the internal energy for wet steam, that is U wet is equal to. Now what is the formula for enthalpy to calculate for the enthalpy for the wet steam? So we know that it is HF plus XHFG. So we have to put instead of H minus P we will write as it is because this process is taking place at constant pressure. And what is the formula to calculate V for the wet steam? So for wet steam it is XVG, that we have already seen in the first video. Then we will move for the superheated steam. So we can say that U superheated is equal to. Now what is the formula to calculate the enthalpy for the superheated steam? So we know that for the enthalpy of superheated steam, Hg plus Cp, in the bracket we have to take the difference of temperature, that is T superheated minus T saturated. So this is the formula that we have already seen for the superheated steam for the enthalpy. That is Hg plus Cp, that is the specific heat of superheated steam multiplied by the temperature difference, that is T superheated minus T saturated. Then we have to take P as it is, that is pressure, so we will take minus P. Now specific volume for the superheated steam. So specific volume for the superheated steam, what is the formula? That is Vg T superheated by T saturated. So these three formulas are important to calculate the internal energy. Now we will solve one problem to calculate the internal energy. Now what is the question? So here 2 kg of steam at 10.3 bar pressure is given, and for this 10.3 bar pressure the data is given. Now we will read this given data. P, that is pressure in bar 10.3. So for this pressure, saturation temperature in degree Celsius 181.1667 it is given. Then the specific volume in centimeter cube per gram is given. Now we know that what is the standard unit, that is the meter cube per kilogram. This is the standard unit, but this is given 189.375. Then HF, that is the enthalpy of the saturated water, is given kilojoule per kilogram 768.458, and Hg, that is the enthalpy of dry and saturated steam, is given 2570.85. So this is the given data. Now we have to calculate what is the volume, enthalpy as well as internal energy. So here mass is given 2 kg. So from this given data, we have to first calculate what is the specific volume and specific enthalpy. Then if we multiply this with mass, then we will get the total volume and total enthalpy. So for this total volume and total enthalpy, we will use the notation capital V and capital H. Now first condition, it is given that the dryness fraction 0.85. So whenever the dryness fraction, that is X, is given, that means this is the wet steam. So what is the condition? That is wet. And second condition, it is given that dry and saturated steam, and third condition, it is superheated steam. So for these three conditions, we have to calculate the volume, enthalpy and internal energy. Now we will first take the volume. So for wet steam, what is the formula to calculate the specific volume? So for wet steam, we have to multiply with this X, that is X into Vg. And when we multiply with this mass, then we will get the total volume, that is capital V. So X is 0.85, Vg, so it is centimeter cube per gram. We have to convert it into meter cube per kilogram. So for this centimeter cube to meter cube, for the conversion, we have to take here as a 10 raised to minus 2. And for this cube, we have to take outside the bracket, there is cube, divided by, for this gram to kilogram, that means it is 10 raised to minus 3. So when we solve this, it is 10 raised to minus 6 divided by 10 raised to minus 3. And here we will multiply with this mass. So what is the answer? 0.322 meter cube. Now we will calculate the enthalpy. So mass multiplied by specific enthalpy will give us the total enthalpy, capital H. So this mass M. Now enthalpy for wet steam. So we know that HF plus X into HFG. But how we can define this HFG? So HFG is equal to Hg minus HF. So this is the formula, because here Hg and HF is given but HFG is not given. So we will calculate here Hg minus HF. So this Hg and HF term, that we have to take inside the bracket, X 0.85 HF, and outside the bracket there is 2 because mass. Then 4601 kilojoule, that is the value for enthalpy, capital H. Now we will calculate the internal energy. So this total internal energy, capital U, is equal to total enthalpy minus pressure multiplied by the total volume. So here if we observe capital H, that is total enthalpy, is calculated 4601 minus pressure P. So this P is given in bar, but what is the standard unit? Standard unit is kilopascal. So for this bar, we have to convert into kilopascal. So we have to multiply here with 10 raised to 2. So we will take 10.3 into 10 raised to 2 multiplied by total volume, that is 0.322. So when we calculate this, we will get 4269.33 kilojoule. Now we will move for the next, that is next condition, dry and saturated steam. So for this dry and saturated steam, how to calculate specific volume? That is, it is Vg. That is, we have to take the total volume, that is M into Vg, that is 2 into, now Vg 189.375, we want in meter cube per kilogram. So here centimeter cube, so we have to take centimeter cube to meter cube, that is 10 raised to minus 6 divided by gram to kilogram, that is 10 raised to minus 3. So what is the answer? 0.378 meter cube. Now next is enthalpy. So enthalpy is m into hg, that is the total enthalpy, 2 into hg. So hg is given 2570.85. so answer is 5141.7 kilojoule. And now next is internal energy. So same formula is there, that is U is equal to H minus PV. So H that we have to take minus P we have to consider in kilopascal, that is 10.3 into 100 or 10 raised to 2 multiplied by V, that is 0.378. So answer is 4752.36 kilojoule. Now the third condition of steam given is superheated steam at 220 degrees Celsius with specific heat of superheated steam is equal to 2.2. So first we will calculate the volume. So volume for superheated steam is given, that is M mass multiplied by Vg multiplied by T superheated by T saturated. Now remember, here we have to take this temperature of superheated steam and saturated steam in Kelvin. So this temperature is given in degree Celsius, so we have to convert it into Kelvin. So we will put the value 2 multiplied by, now this specific volume Vg 189.375. Now standard unit is meter cube per kilogram. So 10 raised to minus 6 by 10 raised to minus 3 and in the bracket 220 plus 273 divided by 181.167 plus 273. So when we calculate we will get 0.411 meter cube. Now we will calculate the enthalpy. So total enthalpy, specific enthalpy multiplied by mass. So the specific enthalpy for the superheated steam is Hg plus Cps, that is the specific heat of superheated steam, multiplied by the temperature difference. So temperature difference of T superheated minus T saturated. Now if we observe here, if we take the difference when the temperature in degree Celsius or temperature in Kelvin, then this difference is same. So we will take here the temperature in degree Celsius as it is, that is 220 minus 181. Now if we take this temperature in Kelvin, then also this difference will remain same. So we can either take in degree Celsius or take Kelvin. So we will put the value 2 in the bracket Hg, that is 2570.85 plus 2.2 in the bracket 220 minus 181.1667. So answer is 5312.66 kilojoule. Now we will calculate the internal energy. So internal energy U is equal to H minus PV. So H is calculated, V is calculated. Now pressure we have to take in kilopascal, that is 10.3 bar multiplied by 100, that is 10.3 into 100 kilopascal. So when we calculate this we will get 4889.2 kilojoule. So this is the answer.